Okay, guys. So today we're going to talk about dividing polynomials by a binomial. The good thing for you guys is that a lot of this requires prereq knowledge on factoring, and I know that we just talked about factoring with our factoring brochure project, so we should all be fine-tuned on factoring. You will see after a few examples that this should seem to be an easier topic that we've talked about. So if we take a look at the first example here, we're going to key in here on this example right here. We have x squared plus 7x minus 8, and that is all divided by x minus 1. So when we are dividing polynomials, our goal is to be able to take this numerator here and factor it, okay? And we can factor this using the AC method. At this point, we should feel pretty comfortable with factoring. The numerator should factor into x plus 8, x minus 1. And then we just re-drop down our denominator. Okay. And what I want you guys to see here is when we're dividing by a binomial, now we can see that we actually have the same binomial in the numerator and denominator. So what we are actually able to do is we are able to take this and we are able to simplify that down, because that is really just like saying x minus 1 over x minus 1 is equal to 1. So our final solution here is just x plus 8. Okay. And if that didn't quite make sense, what I'm going to do is I'm going to go through quite a few examples here. That one was a very simple example with a very simple polynomial, a trinomial I should say, to factor in the numerator. So if we take a look at one like number 3 on my screen over here, let's just say we were given the example y squared minus 25 over y plus 5. Our goal here again, step 1, factor the numerator. So my numerator, I should notice that that is actually a difference of squares. And the numerator can factor into y plus 5, y minus 5, okay, and that is all over y plus 5. What we're able to do is simplify out the common factors now. So we are able to simplify this common factor here, the y plus 5, and the remaining factor is our solution. So our solution here would just be y minus 5. Okay. Again, I will do quite a few more examples with different factoring techniques going on in the numerator. As you can see, that one was a difference of squares. Let's just see if I can find another one. This one's fairly elementary. 10x minus 15 over 2x minus 3. What we'll be able to see here is that the numerator, we're actually factoring the numerator by using a greatest common factor. The greatest common factor that 10x and negative 15 both share is a 5. What I'm left with is 2x minus 3. And that is all over 2x minus 3. And what I'm able to tell here is that, we can cancel out our common factors. And by canceling, I mean 2x minus 3 over 2x minus 3 is another way of saying 1. So we can just get rid of those right there and be left with our final solution as just the constant 5. I'm going to attempt to go into just a little bit of a more challenging problem. Not that I think this is super challenging for you guys. However, this is going to be the latest method of factoring that we just reviewed. With that being said, our new example is 2x squared plus 5x minus 12, and that is all divided by 2x minus 3. So again, our goal here is to factor the numerator, and what we'll see with the numerator is that we need two numbers that are going to multiply to negative 24 but add to 5. And I think what I'm able to use here is 8 and negative 3. So I'm going to rewrite the numerator, and instead of writing this 5x, we're going to rewrite it as 2x squared plus 8x minus 3x minus 12, and that is all over 2x minus 3. Now again, I will highlight this for you guys. Again, this 5x right here, what we've done by factoring is if we've sneakily rewritten that 5x using 2 terms, and now we have 4 terms, so we are able to factor the numerator here by using grouping. So if I go ahead and I factor the numerator, I'm going to start it down here in the bottom left corner. We are left with a 2x, and this becomes x plus 4. And then with the negative 3x and the negative 12, I'm able to pull out a negative 3, and that becomes x plus 4. Again, if I'm factoring by grouping, what I have in parentheses better match up. This is all over 2x minus 3. Okay, and we're still chugging along here. We're factoring the numerator. The numerator will turn into, let's see, 2x minus 3 times x plus 4. That is all divided by 2x minus 3. And this seems to be working out pretty nicely for us, because what I'm able to notice here is that we've got this common factor that we can kind of simplify out, and we are left with our final answer being simply x plus 4. Let's see. And I will do one more quick example for you guys. Just another way that we can rewrite dividing polynomial problems. They all mean generically the same thing. So let's just take a look here. Erase. Another way that some of these problems can be rewritten would be, let's just say we're taking a look at x cubed minus 3x squared. So we have x cubed minus 3x squared plus 8x minus 24 plus 8x minus 24. And what they'll do is they will actually write this division symbol here and divide that by x squared plus 8. What I want you guys to see is that these actually mean the same thing. X minus 3x squared plus 8x minus 24 over x squared plus 8. So whatever way is more comfortable for you guys, I'm going to go in now and I'm going to take a look at the numerator. I'm going to factor the numerator. I'm taking a look at the x cubed and the negative 3x squared. Those share an x squared. And what I'm left with is x minus 3. And then I'm going to take a look at my 8x and my negative 24. And what I'm able to do is pull out that plus 8. And then I'm left with an x minus 3. And then the denominator is just going to slide back in here. X squared plus 8. Do that little simple rewrite here. Left with x squared plus 8. X minus 3. And that is all divided by x squared plus 8. And lastly, we will simplify out our common factors. Again, the x squared plus 8 simplifies out. So what I'm left with is my final solution, and that is x minus 3. All right, thank you guys for watching the video on dividing polynomials by a binomial. If you guys have any questions, feel free to shoot me an email or send me a message on Google Hangouts. Thanks for watching, guys.